Right now, this moment is my favorite time of the entire year, the morning of Graph Connect. Welcome everyone, we're going to have a fantastic day today. So my name is Emil Eifrem, and I've been dabbling in graphs for a while, as Utpal alluded to. He mentioned that Graph Connect in 2012 was our first Graph Connect. What he didn't mention is that it was actually here at the Hyatt in San Francisco, in this room. But as he mentioned, we were about 200-something people. I think we said ourselves we were 250, but I remember my then 6-month-old daughter was here, and she had a badge. I'm sure we counted her as well, as an example. Today, setting aside speakers and sponsors and Neo technology staff, we have over 1,300 people registered for Graph Connect. Isn't that amazing? 4 years, 1,300 people. I think that's quite extraordinary. So we have a little bit of routine for this, and some of you have been around for a while. I see some familiar faces. So one of the things that I always say at the beginning of Graph Connect is that I establish the ground rules, right? And my ground rule is that I do not want your undivided attention, right? We have Wi-Fi, it works. I tried it out earlier. Let's see if it works if 1,300 people go online at the same time. And tweet about this. Let us know if we're doing good, if we're doing bad. Feedback. The only thing that I ask of you is that you use the Neo4j hashtag, Neo4j, or the Graph Connect hashtag Graph Connect, because we monitor those religiously. We're almost getting the slides up and running. That's awesome. We'll get there eventually. This will help. So this has been a quite extraordinary year for graphs. It's been a year since we were last here. Well, we were last in San Francisco talking about graph databases, and there's been a number of things that have unfolded since then, and I'm going to go through a number of them throughout this next 90 minutes. But I think the biggest one is this. The Panama Papers, right? So the impact of the Panama Papers in the world has been huge, probably more so in Europe than in North America. It was an even bigger story in Europe than in North America. But it was just one of the biggest news stories, if not the biggest, for several months worldwide this spring. It was also huge for the world of graphs, because it turns out that the underlying technology used to make sense of that data set was actually a graph database. So I don't know if you all remember the Panama Papers, but we actually have a dedicated session on it later today. But really briefly, the background is that a newspaper in Germany, I think in Munich, was contacted by someone who worked or at least had access to data from a law firm in Panama doing offshore accounts. And they basically gave them a breach of their data, a leak of their data. And they said, this is all the data from this law firm since the 1970s, since the late 70s. Digital copies of emails, forms, like all kinds of things. They said, there's been shady stuff going on, and I want you guys to investigate it, right? What was fascinating about that is a number of different things, but one is the sheer size of it. This was the biggest, supposedly at least, the biggest leak in history, right? If you look at some other leaks, famous leaks like the Snowden leaks or the WikiLeaks, they're pretty big. But the Panama Papers leak was over 11 million documents, right? And we live in a world now where millions may not sound like big, right? But think about it, these were actually physical documents originally, right? So 11.5 million of those. So imagine then that you are the Süddeutsche Zeitung, the name of that newspaper, and you get this dump of over 11 million documents, scans of forms, passports. Like, how do you make sense of that, right? It's very, very difficult, obviously. So what these guys did is that they reached out to an organization called the ICIJ, the International Consortium of Investigative Journalists, who had a history of being able to take these types of leaks and make sense of them. And if we take a step back from technology and we just think about these journalists who sat down there, what is it that they want to do, right? And really conceptually what they want to do is that they want to find individuals, right? Let's say that you have someone, a politician, officially looking person, right? And that person may be connected to a bank account, right? To a bank through an account like this. Nothing wrong with that. That's all of us, right? But you really want to try to find patterns and potentially suspicious patterns. So what if this individual was connected to an address, and on that address, another human being lived, and that person was connected to a company, as an officer of a company, which was registered with a bank in an offshore country. That would not at all be illegal or anything like that, but that's suspicious activity that, as a journalist, you might want to look into. Why is this politician living at the same address to someone who has an account in an offshore tax haven, right? So really what you're looking for here is not the direct connections between an individual and something, but the indirect connections, right? Of course, in the graph world, we call this nodes and relationship. And just that simple thing that we just did there conceptually, nothing to do with databases or third normal form or ER diagrams or nothing like that, right? We were creating a graph, right? A graph is a super simple data structure. I'm sure most, if not all of you in this room know it, where we take these rings on the screen here and we call them nodes, and they typically represent entities, things, physical or abstract things. And then we have the connections between them, that are called relationships. And they denote things like, I'm connected to this person. They have a type, because that I'm connected is typically not sufficient. It's very important to know, or valuable to know, if I'm friends with this person, if I'm married to this person, or if we're co-founders or co-workers or whatever it may be. On top of these two abstractions, the nodes and the relationships, you can attach properties. These are key value pairs, names, for example, right, on the people. And then maybe on the friends relationships, you may attach a weight. On a scale from 1 to 10, we're 3 friends, right? Or we may attach a date. We've been friends since XYZ date, right? The fact that you can attach properties to the relationships sounds like a small thing. It sounds like an obvious thing. Of course, you should be able to do that to both the nodes and the relationships. But that actually makes the relationships first-class citizens. It's one of the expressions of the fact that they are first-class citizens. And that is a super powerful and impactful part of the graph data model. In fact, if I had to peel away everything and say that what is the one thing that separates graph databases from everything else, it's that fact. We take relationships and we cherish them and we say they are first-class citizens. Not more important than the data itself, the nodes, but as important. What's amazing is the flexibility of this data structure, but what's even more amazing is if you can have this in an infrastructure that can scale out from that size graph of whatever 7, 8 to 11 million, or for that matter, 11 billion nodes and relationships. So that's kind of the basics of graph explained through the Panama Papers. So the question then is, all right, so that's the fundamental capability, but where then are graphs being used today? And this has been one of the things that have been maybe the biggest change since we were last in this room in 2012, all 200 or so of us, right? Back then, the way we talked about graph databases is identical to how we talk about them today. We talk about the value of the technology, the value of the data model, its flexibility, the performance advantages that you get, agility in development, schema-free, flexible nature, like all that stuff that as developers we love and we cherish, right? But what we've learned over the past couple of years is that we've seen these use cases emerge, right? It's a completely horizontal technology. Fundamentally, relationships in data, I think owing to how the human brain works, we think associatively, right? It's a completely horizontal, fundamental part of data, right? So it knows no barriers, it knows no industry, it knows no use cases. But it's clear that some use cases have emerged as earlier and more popular than others. And we've been able to start to articulate them. And what's important about that is that we help people bucket things, right? We can shortcut a little bit the old kind of NoSQL theory, or practice, I should say, rather, of matching the shape of your data to your data model. That's fundamentally how you figure out. If you look at the shape of your data and your workload, then you need to try to find a data model that fits that data and the workload well. That's the fundamentals of what happened the past 5 years in the data world. Prior to that, you put everything in a relational database, right? But the use cases help us shortcut that. Oh, if I have a project like this, then I probably have graph-shaped data, and I should look into a graph database. And so some popular use cases today include real-time recommendations, right? So imagine that you're a big retailer, right? For 30, 40 years, you've stored the purchase history, right? And you've stored it in a way that it's customer ID, date, amount, and product ID, right? And then the next row, and then the next row, just a long list like that, right? Well, what if you take exactly that same data, no new data, no fancy machine learning algorithms, nothing, just take that exact data, but you take a graph view of it as well. And then you see that there's a guy called Emil, and he's bought these 3 products, and there's a guy called Utpal, and he's also bought the 3 products. Cool, so maybe it looks like these guys have similar purchase patterns, maybe they have the same taste. So then let's take that 4th product that Utpal has bought that Emil hasn't bought and recommend it to him. Super simple, collaborative filtering, open triangle recommendation, but very, very impactful. And when you do it in the real world, you don't want to do it exactly as simple as that, because you probably want to look at product hierarchies. So rather than recommending exactly that particular book that Utpal had bought but I had not bought, you want to look at that book belonged to a genre. Maybe it's a sci-fi book, which in turn belongs to fiction books, which in turn belongs to books, right? And you want to recommend up and down that hierarchy. So imagine doing that on all the products, and you can see that in order to do this recommendation, you need to do not 4 or 5 hops, but maybe 20 or 50 or 100 hops, which is something that uniquely graph databases can do. So example of companies that are doing that today are many. One of them is Walmart. Very common and popular use case for graph databases. Another one is fraud detection. Fraud detection traditionally has been about mapping out different parameters. You have on the x-axis, you can simplify it to think of it in 2 dimensions. Like on the x-axis, you have something like number of transactions, right, per account, maybe. And on the y-axis, you have size of transactions, maybe. And then you map all the transactions, and you look inside the band of normality. That's okay, but then you see outliers, and you investigate them. Very simple fraud detection. What that won't catch, however, is what's called fraud rings. When you have a number of individually okay transactions that all work within the band of normality, but they form a fraud ring, right? That's exactly very relationship-oriented and exactly what graph databases are very good for. This is one of those examples where unfortunately we can't speak public about the customers because people aren't very willing, and rightfully so, to speak about what they use to detect fraud. But many of the big banks in the world today use Neo4j to detect and investigate and prevent fraud. A third very common use case, very popular, is network and IT operations, which fundamentally, of course, if you're a big telco, your entire world is that of networks. It's telco tower, it's gears, it's switches, it's routers, right? And how they're connected is very important. If this cell tower falls over here, how's that going to cascade across my telco network? Or on the enterprise side, if you run a big data center, right, what happens if I have breach over here, like a security vulnerability? How can that cascade across my network? Those kind of things. Great example here is HP, which has a product in the space that embeds Neo4j. The 4th popular use case, and we have 6 of them for those of you who are keeping count, is master data management, which is one of those topics that maybe not everyone knows about, but as a data geek, it's very exciting. It's about storing the so-called master data of an enterprise, which includes products, it includes people, organizations, suppliers, etc. Turns out that there's a lot of hierarchies here. And we have a team at Cisco actually presenting here today, talking about their approach to master data management, specifically focused around hierarchies using Neo4j. And then we have one of the early use cases on the web for graphs was using using a graph to improve search algorithms for the web. Right? We call this graph-based search or enterprise search with graphs. And that's also a very common use case to augment your normal free text search with a graph to provide better fidelity and better accuracy. Lufthansa is an example of a company here. And then finally, identity and access management. So if you want to have, if you're a big bank, let's say, and you want to onboard a new trader, there's all kinds of collateral that this person needs access to, but exactly which ones depends on which projects you've been to, sometimes even your nationality, which people you're connected to, because otherwise it might be insider trading, etc. That's called identity and access management, or entitlement in the financial space. So this has been really, really important for us because we're able to articulate what we do sometimes to another audience, right? Not to developers per se, but to other people. And you can kind of see where this, kind of the long arc of this. If you pull up, and since we're all online, right? If you pull up an incognito Chrome window, so you're not polluted by your search history, because hopefully you've been to Neo4j.com. If not, you should go to Neo4j.com. But if you then search for fraud detection, you'll see that Neo4j is on the first page for fraud detection, which to me is kind of mind-blowing, right? Think of the billions of dollars that have been poured into becoming on the first page of Google for fraud detection, right? There are entire companies that do exactly that. And that's just one of the things that people can do with graphs, is fraud detection, right? But it's so popular now that people use graph databases so frequently for this that it appears at the first page on Google. As you can see, like kind of our goal with the use cases is, there's the old saying of no one ever got fired for buying IBM, right? And kind of the way we think about this is that you should have to argue 3 years from now, if you have a project that fits in any one of these 6 use cases, you should have to argue why you're not using it, if you're not using a graph database. It may be correct for that project, but the default should be to be a graph database use case. And then, of course, these are just 6 of the top ones. There's 10 more and 20 more. And so that's kind of the path towards world domination for graph databases, become really the default backend to highly valuable use cases like this. So this has been very important for us, but another trend that I want to spend some time talking about that we've seen really since the last Graph Connect a year ago, and really accelerating in the past 6 months, has been a shift in graph database adoption. Where it used to be that we were exclusively chosen exactly like I said here, right? For specific use cases, a database for specific use cases. But increasingly now, we are being selected as an enterprise-wide standard. And that's a very dramatic shift that has happened really just over the past 6 to 12 months. It's starting to happen over the past 6 to 12 months. And the big question then is why? Why is this happening? Because this is a kind of a remarkable thing. And in order to address that, I want to take a little bit of a detour, right? So a couple of researchers at Yale a few years ago did a fascinating study of the S&P 500, where they looked into the average company lifespan. And I don't know if you've seen this. I've seen this probably about 10 times. Every time I see it, I fall off my chair because I think it's so fascinating. So back in 1960, the average company lifespan on the S&P 500 was 65 years. And look how that's developed over the past 50 years. Right? It was 30 years back in 2000. It's around 20 now. And it's predicted to hit less than 15 years in about 5 years. Isn't that amazing? And at present rate, what that means is that in about 10 years, 75% of the S&P 500 will be replaced. Think about that. 75% over the next 10 years. And what's fascinating about that, I think, is that this is true for the S&P 500, but take any list, like of your industry, if you're in retail or finance or health or whatever, and take any stage of company life cycles. S&P 500, of course, are very big companies. But this is true really for anyone, 75% due to the rapidly changing business landscape will be replaced over the next 10 years, right? This is, of course, because of how technology affects all industries, and some people even say it infects all industries. But it really, it places an interesting pressure on companies over the next few years, right? And so the question then is, how can we make sure that our companies are in the 25%, the winners that survive, right? And there's a lot of things to be said about this, but what is very clear, I think, to everyone in this room and definitely to the so-called experts in the world, is that data is a key competitive advantage, right? Data is the new oil, some people say, right? But I think what we uniquely in this room understand is that while data in isolation is very valuable, like connected data is extraordinarily valuable. And some of the companies that have really the most sustainable competitive advantage have been able to use connected data for this. And one of the most stark examples of this, I think, is Google, right? Google was the 15th search engine that came to the market back in the late 90s, right? There was no way that they could win, right? But the one thing, they did everything identical to the Alta Vistas and the Yahoos and the X-Sites and the Lycoses and the InfoSeeks and whatever of the world, if you recall those names. Everything identical, except the one thing that they did differently was that we're not just going to look at data in isolation. We're going to extract the links. We're going to put that in an infrastructure that allows us to traverse those links, and we're going to rank the search results based on that. So really what they did is that they took the data that was core to their business and they connected it. So then thinking back about the 75% and the 25%, what we can learn here from Google, I think, is that what is core to our business has to be connected. So imagine then if you have an enterprise where everything is connected. All the data ultimately is connected. Your supply chain is connected to your CRM, is connected to your marketing technology, is connected to your logistics, is connected to your customers, is connected to your payments history. Everything is directly or indirectly connected. This is much like in the Panama Papers. It's either one hop away or two hops away, but you can take any piece of information and you can track how it relates to everything else at the enterprise. That, I think, would be an extraordinarily powerful thing, in particular if you have those connections in a format where you can act on them. You can inspect them and you can run the business on them. We call this the connected enterprise. And this is one of the biggest things, I think, that is driving this adoption that we see from the specific use cases to an enterprise-wide standard. And these are the companies that are going to remain in those 25% winners. So that sounds a little bit abstract maybe utopian. So let's take a little bit of a deep dive in that, right? So we have today customers across the entire industry, right? In retail, in telco, in finance, in healthcare, you name it, right? The one thing that binds them all together, that unifies them, is that they've seen two things, right? The first one is that there's extraordinary value in connections, in connected data. But secondly, they're held back by their legacy, right? They're held back by relational technology that fundamentally can't do relationships very well, and by relational technology in silos, right? So data in silos as well as data that cannot be easily connected. And so let's double click a little bit on that and take an example to make it a little bit more practical of how we see this unfold, right? And talk about retail. So retail is a very popular industry for us today. Then some of the things that people do in retail are routing and delivery. We've had eBay present on this at Graph Connect before. One of several projects at eBay today. Real-time product recommendations, I mentioned this one already. And then kind of the flip side of that is personalized customer experience, which is another use case where graphs are used to put the customer front and center of your business. Now, there's a bunch of challenges in retail. Front end is not one of them. Writing a mobile app for a retailer is actually trivial, right? Any student can do it. In fact, they all look the same. I don't know if you use any of these, but they all look the same, right? What's hard is getting the back end and the data in place to be able to act on that UI. If we actually take a look at this little, the mobile app here, and we look at the labels, and we think about what is required behind the scenes to make this work, it's actually pretty sophisticated, right? So let's take pickup in store as an example, right? What's required? It's very easy to put the label up there, but what's required to make it work and make it work well? Well, you need a completely up-to-date view of your inventory, right? And that may seem, if you're not in retail, that may seem like, well, of course, you know, I mean, I'm the software guy. I can code a counter. You know, I know how many shoes. That's not hard to do, right? But the retailers that we speak to, I was just talking to one of the biggest retailers on the planet a few weeks ago, and the way that they actually manage inventory is that they have kind of this weird blanket thing that they do that on average we sell 3, let's say shoes, they don't sell shoes, but like 3 shoes every day. So I'm going to just subtract 3 every day from my inventory count. And then a couple of weeks later, I'll reconcile it. Finance will reconcile it and arrive at the actual number, right? If that is your backend, if that's your data, then doing, ship locally or pick up in store is going to be very, very difficult. The equivalent one on the real-time recommendations, right? But really what you want to be able to do there is look at not just the purchase history that I described before, but you want to look at how those products relate to each other, how this customer relates to other customers, look at their pattern behavior, etc. A big connected mess, right? So the question then is, so why don't people do this? Well, fundamentally it comes down to what I said before, right? Where the challenge is, if you want to achieve this at scale, is that your data is stored in relational databases and in silos, right? In relational databases, people love to paint the fact that if you're a proponent for one database, you need to be against another. I'm a huge fan of the relational database. I think the relational database is an amazing piece of engineering and an amazing piece of computer science, a great invention which serves the industry extremely well. But it's not good at everything, and one of the things that it's not good at is connections, right? So you have this data trapped in relational databases. When it comes to the connections, very hard to make sense of them. It's also very hard to draw relationships across silos. In fact, that's impossible. It's not even hard, it's impossible, right? Which means that when we want to start doing these cross-silo things in order to do those amazing recommendations or the same-day delivery, that ends up being a big problem. And so what we're seeing now, for example, in retail, is people starting to unlock this. And how they do it is actually very simple and very practical, right? So what they don't do is throwing away their legacy system, right? That's always a huge, huge tax, so they don't do that. But one of the benefits of graph databases is that graph databases can very easily coexist with a relational database, right? So I have a lot of customers who've said, all right, I want to keep my relational database around, but I'll take the connections and I'll move them over to the graph database, right? And then I'll query the connections in the graph database, and I'll query the other stuff in the relational database, right? So start doing that, and maybe these are your products, and then you can start doing your recommendations, right? And then after a while, they say, okay, there's a lot of value in that, in those connections, so I'm going to take another one of my silos, and I'm going to put the relationships or the entire data, but up to them, and put that in a graph database. And then they take the third silo and they say, like, all right, well, maybe now actually I don't need to replace that with a standalone system. Maybe I'll just add it to the existing graph infrastructure that I have today in order to cross over those silos and be able to use both of the data sets simultaneously. Right? You can kind of see that we're painting two worlds here, right? One is the world with the relational technology in silos. The other one is the connected data view. And then imagine writing some of these new services, right? Same-day delivery may not even be possible if you have a relational database. eBay famously said that when they started doing same-day delivery, their fastest deliveries were 30 minutes. They started out with MySQL and it worked okay, but ultimately their slowest queries in MySQL was 45 minutes. So their fastest deliveries in the real world were faster than their slowest queries, right? So maybe you can do same-day delivery with a relational database, maybe, but it's a lot easier when you use a graph database. And I happen to pick up 3 value-add services here. The list could be 10, 20, 50, right? So this is why today almost half of the leading retailers in the world are using Neo4j. And this is not a retail trend. This is happening in all industries where we see this data trapped in legacy technology and silos is over time converging towards this graph view and the connected enterprise. So we can say a lot of things about the future, but one thing is very clear is that it's highly, highly connected. And here are some examples of companies that are doing this journey right now using Neo4j. So speaking of the future, I want to take an opportunity to introduce our first guest speaker. When I first, I'm Swedish, as you can probably hear from my accent, but I moved here to the Valley in 2011. Before that, I spent a lot of time traveling here to Silicon Valley, and we talked to a lot of interesting companies. For example, met very early on with LinkedIn and talked to their founding team. Talked about how they work with graphs. And Neo4j, of course, LinkedIn is one of our customers, as you probably know. But when I started talking to the management team, I found out that many of the companies that I respected highly, they were funded by this VC firm here called Sequoia Capital. And even more than that, many of them had this one guy on their board, right? And it's a guy called Mark Kwame. So I'm like, who is this Mark Kwame guy, right? And he was on the board of LinkedIn, he was the board on another database company called Merclodic, he was the board on Astrodata. He just appeared everywhere. And all the companies that I respected, this guy was involved. Fast forward a few years, and he's now in Ohio running many, many things. One of them is an extraordinarily interesting company called FactGem, which I'm sure he will tell you a little bit about. And he is also a co-founder of a new VC firm in the Midwest called Drive Capital. So please join me in welcoming up on the stage, Mark Kwame.
Wow, a lot of folks here. Well, thank you, Emil. It's very brave of Emil to have a Norwegian up on stage, being that he is Swedish, because, nordmenn og svensker, de liker ikke hverandre, ikke sant? Anyway, so we're going to get going here. So what I thought I'd do is, I've been very fortunate. I grew up in Silicon Valley. Now, many of you people would ask, why did you go to Columbus, Ohio? That's another story. But I grew up in Silicon Valley. I was very fortunate. My father was a co-founder of National Semiconductor in 1967. I got to see the first personal electronics, the first calculator, the first digital watch, the first digital alarm clock, all this stuff. Then I was very fortunate to work at Apple Computer at age 19 and saw the emergence of the personal computer. Got to work with Steve Jobs for over 12 years on a whole bunch of cool projects. Then I got to see the emergence, obviously, of computer networking with Cisco, and then, of course, what was happening in the internet. And I joined Sequoia in the late 90s, and was very fortunate to see Google when Google was 20 or 30 people, and Yahoo was very early. In fact, my company, CKS at the time, did the first website for Yahoo, launched Amazon, launched eBay. Actually, one of the biggest mistakes I ever made was the founders, Pierre of eBay, said, I'll give you $100,000 to design our logo on a website, I'll give you 3% of the company. We took the $100,000. So I'm not very smart. But so as I've seen all this stuff, from semiconductors to personal computers created computer networking created the internet created, of course, all these wonderful internet applications. And everyone always asks in the Valley, what's next? Well, I really think this is what's next, as Emil has so well put. This is actually a little talk from a report. I'm sure many of you have seen the Mary Meeker report. But she really thinks data as a platform is what's next. And why does she think that? Is because the amount of data that we are creating from all our devices, from everything that's in our hands, from the Nest in our house, to the phone in our pocket, to the Fitbit on our wrist, to the computers and all that. We're creating a ton of stuff while the cost of infrastructure is falling dramatically. I remember when I started working at Apple in 1980. Literally, my CubeMate, Wozniak was like 3 cubes down, but my CubeMate had a 5 megabyte hard drive. It was literally bigger than my arms extended and about 2 feet wide. And when he started it up, I felt the lights dim. Okay? I mean, today, that is 2 photographs. So now, I was just talking to the folks from IBM here. People throw around words like, terabytes and exabytes and petabytes. Like, oh yeah, no worries, So things are happening very, very quickly. And it's all coming from all these different places we know about it. And so what Mary really sees is, it started with the network, going to software, going to infrastructure, and then, the data. And what she says is the next big wave is leveraging this unlimited connectivity and storage to collect, aggregate, correlate, interpret all of this data and to improve people's lives and enable enterprises to operate more efficiently. I think she is absolutely right here. I think her conclusion is absolutely wrong. Okay, and I'll tell you why. what she really sees is, she sees, actually, how do I go back a slide in this thing? Can I go back a slide? Is that possible? So anyway, what she sees is the current application architecture. She sees, SQL on the bottom. She sees data-centric security management, organization-wide of these different platforms, and it's pretty much the same old thing. I don't think that's going to happen. I think, as this cartoon so perfectly states, so far big data investments have just made your stupidity more scalable. Because what's happening is everyone thinks, oh, it's going to be Hadoop. Oh, great, we can throw everything into a data lake, okay, and then we're going to access all this stuff. Well, it just sits in the lake. It's not accessible. You can't really do much with it. Okay, there's all these different things that people have talked about. So what I think is going to happen is the next stage is graph. And I'll tell you why I believe that. A Fortune 500 company, this is a CEO of a Fortune 500 company who really understands what's going on. He says, we have discovered the value of the relationship between the data is more important than the data itself. And by the way, this CEO is in his 70s. He really understands that the relationship is more important than the data itself. Now, we've seen that before. As Emil stole from one of my slides, it first started with Google. Remember, Alta Vista was all the rage, okay? Because why? They had amazing crawlers. They could crawl the web, and they'd pre-process it at night, and you'd be able to find all this stuff. But what Google realized is PageRank. What relationship your page is to the other page. If you're connected to Time Magazine's page, or if you're connected to NBC's page, or you're connected to this, you are more valuable than if you're connected to the XYZ blog page. Okay, PageRank ranked the value of the relationships. Also, Reid Hoffman. I'll never forget when I met Reid for the first time. LinkedIn had about 8 people. And LinkedIn basically, Reid said, yeah, Monster, by the way, at the time was this $1.5 billion, $2 billion company. It was growing, this amazing company. And what Reid said is, the relationships between people are more important than the people themselves. What I want to do is create a graph of 300 million white-collar workers across the world. He did it and did okay. PayPal, same thing. I mean, basically what PayPal was able to do is very quickly understand, through eBay and other things, understand the graph to get people paid. So we have seen these things, people utilizing these technologies in innovative ways. So what I fundamentally believe is going to happen is I think the enterprise stack is about ready to get completely changed. I think we're going to enter the time of the enterprise graph. And what I thought I'd do is give you a quick case study. My whole philosophy is, if you can go up on a whiteboard and actually draw your business, okay, customer buys a product is at a store has a, you can draw this. Why can't a computer work like this? The problem is, all of this information is in hundreds, or sometimes tens or even hundreds of different databases. I've met with one customer that's managing their infrastructure with 140 access databases. Okay, people, because the way SQL works, as we all know, is you can only effectively do 3 joins, maybe 4 joins if you're lucky. By the way, when Reid started LinkedIn allowed unlimited connections. They were built on a SQL stack at the time, using Oracle and Sun. And as the network grew, the compute didn't work. We couldn't compute the graph every night. So we eliminated it into 4 connections and then finally to 3 connections because SQL works really well with 3 joins. And so that's why, for example, at LinkedIn, you have 3 joins in LinkedIn. So what I fundamentally believe is what you're going to want to do is be able to link all this data together in a very, very effective way. Because if you have all the data linked together, then you can do stuff that you have never done before. So this is a chief data scientist from a Fortune 500 company that I really like this quote. The business case for using graph is very easy. We implemented a 360-degree view of a customer integrating 10 never-before integrated databases and enterprise data warehouses in less than 5 weeks. We believe we will save over $50 million with our graph implementation. We are beginning to reevaluate our whole software stack. That, I think, is going to happen everywhere, but this is going to take time, okay? Because most people don't think it scales. Everyone has a reason why not to like graph. There are 1,000 different reasons why not to like graph. What we have seen at FactGym and what I've seen in other places is that people are beginning to see the value. There's a lot of folks out there who love their SQL, okay, and they don't want to give up their SQL. But the tide is turning. And why is the tide turning? Because businesses can't operate anymore in the current environment. You have to be able to have integration of all of your heterogeneous data, or it's not going to work. So we look forward to talking to you more here, and pass it over to Emil. Thank you.
So Mark has a specific session on the technology that he's building with this new company, FactGym, that I really urge all of you to check it out. He's super clueful about many things data, and they're building very, very fascinating things. So I'm going to talk a little bit about product. I talked a lot about market before. I'm going to talk a little bit about product, right? So 6 months ago at Graph Connect in London, we announced Neo4j 3.0. And Neo4j 3.0 was a very, very impactful release for us. It had a lot of features spread out across 3 stages of the product lifecycle, from design to develop to deploy. And we introduced things that probably most of you here in this room are familiar with now, but the new driver architecture, right, with native new language drivers for C#, Java, Python, etc. This is underpinned by a new binary protocol that we call BALT, which is natively optimized for graph operations. And we upgraded our storage engine in the kernel to support unlimited sized graphs, which is a huge deal for us. We did a lot of work on Cypher, our query language, to make sure that it ran faster. We did also a lot of work on the deployment model so that we can be more easily and seamlessly deployed on the cloud, in containers, and on-prem. And then we launched this quite extraordinary feature, I think, that seamlessly integrates with Cypher, called procedures, where you can define your own procedures in a general purpose programming language like JavaScript or Java, and then invoke them from Cypher. Very big, very impactful release that we're super, super proud of. One of the things that we thought were going to be huge, but has surprised us even more with how huge it is this procedure work, right? So there's now a collection of procedures called APOC. This guy here is APOC from the Matrix movies, if you don't recognize him. Of course, we named the project back in 1999, 2000, right, when the Matrix movies were very, very popular. So we're sticking with that theme sometimes. But it's really it's an open repository, community built. And there's over 200 procedures now that have been built by, I'm sure, many of the people in this room. It's quite extraordinary, and I urge you all to check it out. In fact, there's even a booth for APOC outside here in the exhibition hall. So this is a great way for the community to contribute procedures. And it's also a great way to really be a nurturing ground for features that we move from procedures into the product. So one example of this that we're rolling into the 3.1 release is someone wrote a procedure for detecting the schema, really, of a graph. And you might think, why? The graph is schema-free. Well, actually, a graph is schema-optional. As you may or may not know, we have early schema constructs in the database already. Things like you can have mandatory property constraints, where you can say that if this node is labeled as a person, it has to have a social security number, right? So there's actually some schema constructs. But there's no one place that you can usually go to and say, hey, this is exactly the shape of my graph, right? Well, someone wrote this little procedure that took an existing unknown graph database, analyzed it, and showed the schema, which I thought was absolutely amazing. So we've now taken that and rolled that into the 3.1 release. So speaking about the 3.1 release, right? So 3.0 was very, very impactful in terms of developer productivity. The question then is, what's next? And really the theme for Neo4j 3.1 is what I mentioned before, the database for the connected enterprise, supporting, really accelerating this shift from a specific use case database to this enterprise-wide standard, right? And we see two remaining things that we believe is going to accelerate this shift. The first one is our next generation clustering architecture. And the second one is our new security foundation. So those are the two big things that I'm personally most excited about for the 3.1 release. So let's dive in a little bit into them. But first, I want to take a little bit of a detour and talk a little bit about like how we think about building products at Neo4j. Hopefully this is evident from our product, but here's how we think about it, right? So a guiding principle for us has always been, we take care of the hard stuff so you don't have to. That's our goal, right? So one example of this is a picture from me from 6-7 years ago, one of the first NoSQL conferences back in 2009, where I talked about Neo4j. And one of the things that I talked about back then was ACID, the fact that we're ACID, which is something that industry observers also noted. This is Martin Fowler, a highly influential software guy. Many of you probably know of him, or at least you for sure know his work on design patterns and refactoring. He coined the term refactoring, for example. And he was trying to make sense of the NoSQL space back in 2009, right? And he wrote a book, NoSQL Distill, where he said, there's aggregate-oriented ones, and then there's graph, and all the graph implementations are ACID. And really what he meant by that was that Neo4j is ACID, because we were the only implementation around back then. And this was actually hugely controversial, right? Because the kind of discourse in the industry back then was that if you have transactions, you won't scale, right? And we took a very contrarian view on that. We said that, well, if we don't build transactions into our database, then most applications actually do need transactions. And for those applications, like we're going to force our users to re-implement transactions in the application layer, right? And you're going to do a poor job of it. Not because you're not good developers, I'm sure you are, but like writing a transaction subsystem, take it from me, that's a lot of work. You need to be fully dedicated to that for years and years and years, because it's really hard stuff. So by not having transactions in the database, we force all users to re-implement that functionality. We didn't think that was a good idea, so in the notion of taking care of the hard stuff so you don't have to, we said, all right, we're going to make Neo4j fully ACID compliant. So with that as background, I want to tell you a little bit about how we think about our next generation clustering architecture. This is a huge piece of engineering that we worked on for almost 2 years. So I'm so excited to be able to finally talk about it publicly. And this is a highly complicated, deeply technical topic. I'm going to be very, very high level here and talk about kind of the big picture stuff. There's a dedicated session later on by Alistair Jones and Max Summerall, who is an hour or whatever, 45 minutes, just dedicated to this feature. So if you're interested, I really urge you to go check out that session. But there are 4 pillars that I think are especially worth talking about in the next generation clustering architecture. It's ultra-large clusters, it's raft and consensus commits, it's full stack cluster awareness, and it's causal consistency. So let's go into those in detail, right? The first one, the ultra-large clusters, right? So what we've done in the next generation, in the new generation clustering architecture is that we've split it up, right? So we have 2 types of servers. We have what we call core servers, which you can think of as kind of the successor to the old master, the singular master that we had in the previous generation of the clustering architecture. So it's a set of core servers. They read-write. You can apply your rights to all of them, and you really focus all your rights to this set of servers, right? It's a cluster in of itself. It's 3, it's 5, it's 7, that order of magnitude, not bigger than that, right? But then we have a second layer, a new type of lightweight class of servers that we call read replicas. And they are very lightweight, easy to scale out, easy to set up, tear down. They work very well in this kind of cloud mindset where you have elastic things that are easy to set up and then tear down again as you scale up and down your load. Importantly, they support heterogeneous, or the entire architecture support heterogeneous clusters, which is why the green servers here are sometimes, some of them are bigger and some are smaller. And that's to indicate that maybe sometimes you want to have a reporting instance. You hang off a reporting instance off of your live cluster, which is pretty amazing that you can do that. You can do your reporting in real time. But then maybe that machine wants to be a little bit bigger, needs to be a little bit bigger than the ones that you scale out on your commodity servers, right? And having a cluster architecture that supports this heterogeneous thing is I think, very impactful. So the previous generation was designed for dozens of cluster members. This generation is designed for, and it's architected for thousands size clusters, right? So I think that is going to be pretty huge, and I'm very excited about that. So that's the first one. And then the second one is raft and consensus commit, right? So this is also a very, very technical topic, but I'll give you the high levels, and for the details, I urge you to check out that session. But a little bit of a history here, right? So when we first built out our first clustering features, we decided to use an external technology for doing distributed consensus. We chose one out of the Hadoop project called Zookeeper. Many of you are probably familiar with it, right? And that worked really well. But after a while, we realized that, okay, we're really asking our customers to run a Neo4j cluster, and then in parallel set up like a Zookeeper cluster as well, which is just a lot of moving parts. So we said that, all right, hey, let's bring this all in-house instead. And so we implemented our own version of the same protocol that Zookeeper implements called Paxos. So now we're taking that to the next step. So we've looked around, and there's been a lot of research going on in the distributed systems community. And one of the most popular and widely acknowledged as a really solid protocol for distributed consensus, and maybe even the best protocol for that, is called Raft. And the key advantage that Raft has over Paxos is simplicity. And for those of you who are geeking out on distributed systems, you know that simplicity is really everything when it comes to distributed systems, because it's so complicated anyway, so you want to try to have everything as simple as possible. And the way that we're using Raft is also radically different, because we used to only use it only use Zookeeper and Paxos for cluster membership, but now we also use it for consensus rights. So this is really important, because it means that under no circumstances can you have rights that get lost, right? If the cluster has acknowledged a right, unless you actually physically go in and destroy all the machines, right, it is guaranteed to be there, right? And under no circumstances can you have branch data. So I think this is a huge deal for us in the next generation clustering architecture. The third one is what we call full stack cluster awareness. Remember I mentioned Bolt before, the binary protocol that we launched in 3.0. So that has now been upgraded to be completely aware of clusters, right? What that means is that your drivers will be completely cluster aware. And previously, in Neo4j and in a lot of other architectures like MySQL, etc., you sometimes need to keep track manually of your cluster. So for example, you might want to dedicate all your writes to the master. Well, then you need to know which machine is the master and where is it, right? And then you kind of have this awkward manual process where you kind of query the cluster, who's the master, and you do that every 5 seconds, because of course the master may be moved around if a machine falls over, like the cluster is going to elect a new master. So it's just a lot of work. That is all now taken care of. The driver always knows the shape of the cluster, and it will look at your operation. Is this a read operation? Awesome. I think this guy over here is going to be awesome for that. Is this a write operation? I'm going to take this particular cluster member as part of the core set and write to that one. All fully integrated. This means that it now includes a load balancer. Whereas previously you had to use a load balancer, like an external load balancer, that's now all built into the driver architecture. And then finally, causal consistency. Causal consistency. This one is pretty big, right? But before I talk about this one specifically, let me tell you about what is most commonly used today, eventual consistency. How many people in here have heard eventual consistency? Probably most people. Okay, maybe 50-50. So eventual consistency is the predominant way that NoSQL databases or alternative databases scale out today. And it's a very complicated topic, as with everything around consistency in distributed systems. But basically what it means that if you write to a cluster, you update the value to 5. It used to be 4, you write 5, right? Then it's guaranteed that if you read that particular machine, that particular cluster member, you're going to get 5 back. But if you read from somewhere else in the cluster, you may still get 4. eventually, the eventually consistency, eventually it's going to converge and you're going to get 5 across the entire cluster, but it'll take some time, right? It may take 1 millisecond, it may take 5 seconds, right? You don't know. And that's great because it allows you to scale out more easily. However, the drawback is kind of in many use cases, in particular in the enterprise, that level of consistency guarantees is not okay, right? And you kind of, I mean, think about it, you kind of go crazy. I just wrote 5, now I read it back. I happen to be dispatched to another cluster member, and then I get 4. But I just wrote 5. I mean, that just becomes very, very confusing. And so for those type of use cases, like you see all kinds of workarounds that people do. This is very analogous to where I started out. Remember when I said that if you don't provide an ACID database kind of in a single machine, right, you have to re-implement transaction in the application layer. Well, here's some things that people are doing, right? So we're writing to the cluster over here, right? But then we need to get that 5 back. It's not okay for us to get a 4 back if we've written 5. So what we do is that we sleep for 100 milliseconds, right? Which is a solution. It's not a particularly great one, right? It's not even guaranteed to work, and it will slow down all your reads by 100 milliseconds, right? Another thing that people do is that they say, okay, so I was guaranteed if I read from the same machine that I wrote to, I was guaranteed. So all right, so let's just remember the machine that I wrote to, and I'll read from that one. That kind of negates the entire, I mean, it works, but it kind of negates the entire upside of using a clustering architecture in the first place because you can't scale out your load. So what we've decided to do is sticking with the we take care of the hard stuff so you don't have to philosophy. And we've built in this new notion, or relatively new notion, that is called causal consistency, which is a fancy way of saying that it works intuitively the way that it should be. It gets you what's called read your own rights consistency, right? So in this example over here, we're writing something, and even though we're writing to the blue in the middle, even though we're reading from the green, as long as we are the same individual, we're the same process, we're guaranteed to get the most latest thing that we wrote. Read your own rights. This one may sound like a small detail, but it's actually impactful enough, we believe, that we've named the entire architecture after this. So we call it Neo4j Causal Clustering. Those are 4 things about causal clustering. There's a 2-hour session on this alone, right? Easily, in our heads, and there's so many more things to talk about that are beneficial and amazing. So I really urge you to check out that session by Alistair Jones and Max Sumrall later today. So that's the first one, the causal clustering. And the second big feature then is the new security foundation, right? And the new security foundation involves 3 big things, right? So the first one is that while we've had users in Neo4j for quite some time, now we have support for using the enterprise-wide directories that is clearly at your companies. If you're a big company, most of you have an LDAP directory or an Active Directory where you store your users. And with Neo4j 3.1, you can now authenticate your users against that. It supports LDAP out of the box, it supports Active Directory out of the box, and Kerberos is coming next. So that one I think is pretty amazing. Once you now have a user for all your operations, then you can start to assign roles, and this works the way that you would expect it to. So, for example, in the example with the big read replica that you used for reporting, you would assign a role to that one where you only have an ability to read, not write, because you probably don't want your reporting software or people to be able to write to the production cluster, right? So then there's a role for that. And then finally, through procedures, we support fine-grained access control. So this is where you can say really, really nuanced things like, all right, so these nodes, you have access to these nodes, but actually there's a property on here called salary, and you can only read that property if you're in the finance department, right? If you're the recommendation system, you don't need to see the salary of the employees, right? So then you're not allowed to do that. And this fine-grained level of access control is available in 3.1 through procedures. So a lot to be said about this. There's also a dedicated session on security, the security in 3.1 by Igor, the lead PM for the security work. So if you're interested in this, please check it out. What's impactful about this one is that it allows you to be completely compliant with your kind of internal as well as external security and compliance mandates like Sarbanes-Oxley, PCI, HIPAA, etc., which is a really important part of this enterprise-wide adoption. So in summary, those are the two important features that I'm excited about for 3.1, causal clustering, the next generation clustering architecture, and the new security framework and security foundation. Neo4j 3.1, we worked on it for a long time. It's available today in beta. We're launching that today, this morning. We've extended the beta program for this particular release for 2 months because it involves so many moving parts in terms of the distributed systems aspect. And we really want to make sure that once that becomes GA, that it's rock solid. So we expect it to be GA by the end of this year. But I urge you to go to neo4j.com today, /download, and download the first beta and start checking it out. Give us feedback if this is what you're expecting, things you want to see, etc. So that's cool. So we talked about product. Now let me tell you a little bit about an initiative that we mentioned a year ago and that I'm personally super excited about because it's a way to get all of the participants in the broader space to really work together and collaborate, right? Be them other vendors, other graph vendors, or tooling providers, or SIs and whatnot, right? So OpenCipher is this open source community project that we launched a year ago. It is Apache licensed. Its goal is to create a free and open, vendor-neutral query language for graphs. You can think of it as the SQL for graph, right? The SQL for graphs, right? It's based on Cypher, which has been Neo4j's query language for a long time. And I don't know if there's a session on Cypher, but I'm sure every session is going to include some Cypher. If you haven't yet had the privilege of working with Cypher, go out into the graph clinic that we have outside, and I'm sure any one of the Neo4j employees can give you a 3-minute crash course, and you'll be up and running with Cypher right away. Users love it. We think it's been one of the most impactful things that we've done. In fact, when you look at the space, and when the graph database space truly started taking off, was when we included Cypher as the default surface in Neo4j. It was so impactful that the entire graph database space became the fastest growing space in all the big data. That's how impactful it is. So the question is, why do you care about OpenCipher? So I'm very excited about this, right? But why do you care? Well, for your employers, for the companies, right, it's actually really important because you can now safely write your applications knowing that you're not beholden to one vendor. And as I'm a vendor, right? And you can easily fool yourself as a vendor that you want vendor lock-in, right? Because that's short-term the best thing to do. But fundamentally, of course, our goal is to grow the pie overall, grow the entire space. And we want to make sure that we earn your business every day. So the fact that we can be swapped out if we're not good enough, I see as a good thing. And for you as individuals, this means that you can commit to learning Cypher, knowing that it'll run on top of other graph implementations. Your skill set will be go to waste. It's a transferable skill set. So last year I was on stage with an Oracle spokesperson when we articulated our vision around, creating the de facto query language for graphs. So you might you might think, well, what's happened since then, right? So a couple of big things, right? So first off, while the users of Cypher are everyone here in this room writing applications, actually the stakeholders for OpenCipher are tooling providers and other database vendors. So it took us a while, maybe it sounds obvious now, but it took us a while to realize that, yeah, actually, the end users now are kind of different, right? And so we spent a year now focused on the first one of these, the tooling providers. And we've done a lot of work that we call tooling enablement. And I'm happy to announce that as of today, we've published all the required artifacts for you as a tooling provider to be able to implement OpenCipher. And many already have done that. So IntelliJ is the most popular, I think, commercial IDE for Java. And they have support for Cypher today, as one example. And there's plenty of others. What isn't as easy today, however, is if you're another database, it's entirely legally doable, theoretically doable to implement Cypher. However, it's kind of hard today. So that's the next step for us, to do database enablement and make it easy for other databases to implement Cypher. Despite that, there's actually 3 graph databases out there, aside from Neo4j, that support Cypher today through OpenCipher. think that's pretty impressive, actually, in a year. In terms of process, we've moved everything from internal Neo4j systems. Of course, we're open source, so we build everything on GitHub, etc. But like all the Google forums, etc., like all the discussions are now in a Google group. Our CIP process, we have a formalized process for how to change the language, right? It's called SIP process. It's modeled after Scala's process, also called SIP, but with an S. We've moved that completely outside the building, right? So anyone can participate in that. And we've talked to a lot of vendors and tried to figure out what is the best way to remain as open and inclusive as possible when it comes to process, while also maintaining efficiency, right? I mean, those are kind of the two things that we're trying to balance. We've gotten a lot of feedback on the process, as well as on the language. Things like, SQL containment, right, is an important thing that we look forward to tackling together with the participants in the space going forward. Ultimately, today it's not an open standard, right? If in order to be standard, you need to be governed by ISO or ANSI or something like that, right? So we're not that. We want to be that ultimately. We can become a de facto standard even without it. But one thing that has been very clear to us over the year that has crystallized in our minds is that we want Cypher to be governed by an actual public standards body. So that's what we're driving towards over time. So a lot of amazing, fascinating news for this. A little bit of a detour. Simultaneously to all this, we have launched a Spark connector. And this one is really, really cool. It's a way to, if you have data in Neo4j, you want to get that data into Spark because you may have a workload that fits better with Spark than Neo4j, right? And then it's a seamless way of getting your data into Spark and then back into Neo4j today. It works with Neo4j 3.x. It's a very fascinating piece of technology. There's a lightning talk about it later today. Why do I mention that when I'm talking about OpenCypher? Well, the way that we see the graph space evolving over time is that we really see two kinds of workloads. We have the kind of real-time operational OLTP style workloads that is the foundation for Neo4j, as well as the OLAP style kind of analytic compute. But a lot of those kind of workloads are very popular to put in Spark as well. And through this connector, you can now seamlessly move data back and forth between Spark and Neo4j. Over time, as Cypher becomes the language that you speak graph in when you talk to both Spark and to Neo4j, we see a really beautiful architecture emerge where you can have a unified one language to all underlying technologies when it comes to graph, to Spark, to Neo4j, and to others. And we look forward to spending a lot of time on this. And I imagine I will be announcing some amazing things about that at the next Graph Connect. All right, so one final piece of thing before we let on the last guest speaker. We launched a startup program a year ago in San Francisco. I thought I'd update you a little bit about that. And the goal with the startup program is to make sure that, I'm sure there's many startups in here, right? And all of you that have an idea and a purpose, we want to give you a technology that really, the way that I think about it is that we take the Googleplex technology and we put it in your hand, right? And this is something that has been very successful for us. We launched a startup program. If you're a startup less than 20 employees, you get the entire Neo4j Enterprise Edition, all for free. You can use it however much you want. If you between 20 to 50, we have a startup pricing that is heavily discounted, and it's been very, very popular. Today, in fact, we launched it a year ago, and we have 349 startups actually signed up in the startup program. I think that is pretty amazing. I have a couple of facts about them. 32 countries in all kinds of fields of innovation, backed by everywhere from bootstrapped to top VCs such as Sequoia, Excel, Drive Capital, right, Mark? So that one is awesome. But now we've thought a little bit more about this. How can we even serve startups even better, right? So here are some examples of our alumni, right? But how can we serve startups even better? And what we're launching today is what we call the Graph Incubator, right? And what that means is that on top of the technology and the support that we've had as part of the startup program, we're going to do a little bit more, right? And this is early in our heads, and we're trying to figure it out here, so please give us feedback on this one. But we really want to make sure that if you're a startup and you're not a connected enterprise in the future, but you're starting as a completely connected startup, right? How can we help you be successful? So we're going to launch this program that you can apply for, and you're going to get access to mentorship from Neo4j board members and investors and executives, right? I've done a lot of mistakes that I love to share with you, some things well as well, believe it or not. And we're going to do a lot of events around this. We're looking at a quarterly schedule where we're going to give access for the startups in this program to executives at Neo4j and board members and investors and other people in our network. We have 250,000 people coming to our websites monthly, right? And so if you're a startup in the program, we'd love to get the word out about you. Write a blog post about what it is that you do. We'd love to promote it. Video, webinars, case studies, those kind of things. We have the technology and the support. We already mentioned that. And then ecosystem support. We're doing quite a lot of negotiations right now, for example, with cloud providers, where we say, hey, we represent over 300 startups. Dear Microsoft, Amazon, Rackspace, IBM, whatever it may be, you need to give us the type of discount that 350 startups deserve. And we're getting really good headway in getting to a point where if you're a Neo4j startup and you want to run on top of one of those cloud providers, you're going to get it basically for free. It's a heavily discounted fee. So that's kind of some of the benefits of scale that we're trying to achieve with this program. So that's from startups. Now let me take a completely different step and move from startups to a company that isn't quite a startup just yet. I mean, not still, right? It's been around for a little bit of a while. So about 2 years ago, we started our first hardware partnership, right? And hardware acceleration is a huge trend, right? A lot of people look into GPUs for that. We at Neo4j are very interested in I/O, so it became very natural that was our first foray. And we started talking to the IBM people, and we saw, it was very early in the days, we were privileged to see the things that they had in the roadmap and saw some absolutely amazing technology that we really felt that, okay, this could be the next big thing in terms of hardware. We have to be there early, right? I'm not going to talk about it because our next speaker can do it much more justice. But I'll say this. I talked a little bit about connected enterprise. And enterprise is a huge focus for us. I just talked about the startup program, but enterprise is a huge focus for us as a company. And I can think of no better company on the planet that represents enterprise quality than IBM. So please join me and welcome up on stage Mr. Doug Balog, GM of IBM Power Systems.
Good morning, everybody. And we are clearly the skew of the S&P 500 at 105 years old. Not me personally, by the way, but our company is, and have seen quite a few disruption over that 105-year period. Some went well for us, and some didn't. We're going, I think, as Mark and Emil talked about, and really painted the case well, through an incredibly disruptive point in time right now. Now, the role I play at IBM is I run our server business. I'm responsible for the servers that banks around the world use, telcos use, and if you look at the foundation of those, they are data-rich servers, although from a much more traditional relational database sense. So my challenge as I took on this team and technology here 3 years ago was to fundamentally disrupt myself, fundamentally disrupt what we've done with 50,000 plus clients around the world, and bring power technology into kind of this digital era we find ourselves in. So, by the way, if you never thought hardware was cool, I hope in the next few minutes to convince you it's cool to be in hardware again right now. So let's talk about what we see going on. You heard Emil talk about the accelerator technology. But let me sort of paint the broader picture in case you haven't sort of stepped back away from the graph database space and said, what's sort of going on underneath the hood of the car? So there are, clearly if you look at the right side, fundamental changes occurring in the industry. I call these as sort of our opportunity space. You know, we at IBM call it cognitive, you might call it AI, machine learning, deep learning. phenomenal investment going on right now to try to actually have computers that learn. I don't know if any of you saw 60 Minutes here this last Sunday, but incredible efforts going on to consume information and be a tool to physicians around the world, financial institutions around the world, really commerce, any industry is trying to capture the data coming in and make more sense out of it in real time. One of the fascinating stories from University of North Carolina in Chapel Hill, where I happen to call home on the weekends, is from the physicians there. They said 8,000 papers on cancer are published a day. Scary, right, if you're dealing with cancer in yourself or your family. 8,000 papers a day. There's no physician on the planet that can consume that and make sense out of it, experiments going on, trials, and then apply it to your need. That's where a tool like Watson for us comes into play. The cloud and all the cloud companies have taught us over the recent years, it is a custom build market again. Remember back in PCs when you used to build them yourself in the garage? Tinker with them, you made a PC just for yourself? That's what the cloud companies are doing. They don't want a component more or a component less than they're willing to pay for to run their stack of software. Their stack of software. And as you've heard eloquently over here this morning, the data now today, though, is less relational and much more unstructured. It's graph databases and all the other choices of unstructured data that we deal with on a regular basis. So those are the opportunity spaces. Now the bad news part from a hardware. The whole thing that I've lived my entire IT career in was the notion that manufacturing processes were going to double the chip density, double the transistor density, and therefore double performance every 2 years. In case you don't know, that Moore's Law is dead. Fundamental laws of physics get in the way, folks. You know, you can't break them. We've tried. But if you look at the generations of technology we're on, 22 nanometer going to 14 nanometer to 10 to 7, yeah, they're going to keep coming, but those generations are fewer and fewer gains in between. 10%, 20%, 30%. It's not the doubling we're used to. So how do you address the right side, the opportunity space, where you have this incredible wealth of data, demand for insights from it, and yet your computer systems you counted on aren't running faster generation to generation? Oh my goodness, we're in a crisis right now. Good news is we have solutions for that. So back to transforming my little business and the power business at IBM. I think about it in 3 ways. 1, technology, and I'll talk quickly about that. 2, ecosystems and relationships. You guys spend a lot of time on relationships in a graph database. And 3rd, I won't spend a whole lot of time on it, but you've got to be prepared to change your business model. That 3rd one is the part most people forget about in disruption. You can't just keep trying to make money the way you made money when your whole business is being disrupted. You've got to think about new relationships, new royalty models, IP licensing, even new words like freemium. I don't even know what that means yet, but I mean, it's like, is it free or not? It means something different. And so business models as important as technology innovation and as important as new ecosystems. So let me share a little bit just real quick to give you a sense. The power roadmap, by the way, again, these are not Intel chips. So I want to be really clear on that. These are our own design processors that we at IBM design with our research, and we use our manufacturing partners around the world. We started shipping Power 8 in 2014. Next year we'll move with a very clever named product to Power 9. My crack marketing team at work. And in the future we'll move to Power 10. We'll change node technologies, we'll add cores, we'll do all those things. The big bet though we are making, back to this Moore's Law is dead, is that acceleration technology is fundamentally the game changer by which all the new generation data-oriented applications have to work on. So we've got a whole family of acceleration technology that we are building into the chip and building into the system. Technology like NVLink from NVIDIA. This is their proprietary interface that connects a GPU with a really good general purpose processor and a high-speed bandwidth. We burned NVLink into our Power 8 chip as of last quarter. It delivers 4 times the data transfer bandwidth than an Intel system. 4 times, 4x. Nobody else is planning to do that. We've got things like CAPI, again, wonderful technology name product, coherently attached processor interface. It basically says you can hang accelerators off of this CAPI bus and share memory again, back and forth between an FPGA, an ASICs, or a really great processor like Power. We see genome sequencing as a great use for that. By the way, in GPUs, the Department of Energy and the national labs have a plan to spend $300 million with us for the GPU Power 9 connected system. Tomorrow, with the likes of Dell, Google, NVIDIA, and others, we'll be announcing a new CAPI interface we call cleverly Open CAPI, back to the spirit of opening this up for the industry to take advantage of. So if you're looking for what's the big bet we're making around data, the big bet is around acceleration with a really good processor. That's the way in which we see the world evolving to address those problems of cancer research, genomes, IoT data filtering, and the big data problems you're all wrestling with today. So that's our hardware roadmap. Hopefully, as you can see, I'm pretty excited about it, and we hope you are too. Now, how does that apply to graph databases? You heard Emil talk about things such as scale. So with the power system, we have everything from itty-bitty systems, the little 1U servers, 2 sockets, 24 cores. You can actually have less than that if you want, 6 or 8 cores. We scale that if you want, all the way up to a 192-core system or 1,500 threads, about half a rack. So looking for scale of compute, we've got scale of compute. Looking for scale of memory, our systems start down around 1 terabyte, back not 5 bits or 5 megabits, but 1 terabyte in a 1U server, all the way up to 16 terabytes in a system. Now that's just regular memory. If you want to attach flash as memory, which we offer back to that CAPI interface, you can add another 40 terabytes of flash as memory. So you got a pretty big system in terms of the ability for it to house in memory very large graph databases to drive scale. Now, it's not just about scale, as you know. It's also about how do you take advantage of that acceleration to rapidly drive insights. And that's back to technology exploration we're doing with the Neo4j team of how do you take advantage of all this great acceleration technology we're building in the power processor. So hopefully that gives you a sense of kind of how we see this relationship evolving with Neo4j running the power platform, taking advantage of its scale, its memory, its processor, but also its ability to do acceleration. So that's what we're working on with them on the team. Transitioning a bit to ecosystem, because this isn't just a one-way relationship back to this kind of many-node relationship conversation. We recognized here, and this may sound odd for IBM to say, we can't do it all. I know it's sort of like sort of a truthful moment, right, where you stand in front of the mirror and say, I can't do it all myself anymore, right? Long gone are the days of we stay behind sort of cloak-shrouded glass and do it all and then go, ta-da, here's our thing. The days have come and gone. There are great minds in the industry, great minds in this room, and we need to tap into that. So we started a conversation, or Google started a conversation with us about 5 years ago, and it was us and Google, NVIDIA, Mellanox, an I.O. company, and then Tyan, a motherboard company, 5 of us. We started a conversation around those headwinds we saw in the computer industry. That graph I showed at the depth of Moore's Law, how were we going to continue to deliver at least 2x performance every year through acceleration, through new I.O. models, through new memory models, to intelligent firmware, to new system designs? How are we going to do that? So the 5 of us got together and sketched out an idea on a napkin. And we said, what if we bring the concepts of open source software, bring the concepts of the ARM processor. If you're familiar with ARM, ARM is the processor in pretty much every one of your smart devices. How do we bring those concepts and bring it to enterprise servers? How do we open it up and tap into the innovation in the industry? So we created the Open Power Foundation. We let go of technology. I'll license power technology to anybody who wants to license it. Anybody. They can do derivatives of it. They can manufacture it. They can build servers. And that's what we did. That was 2 years ago, 5. We're now over 250, 265 or something as of this morning, companies around the world that are part of the Open Power Foundation. Dozens of innovations, or hundreds of offerings. It's pretty exciting in terms of how openness truly spawns innovation versus a single company owning the innovation agenda from the server industry, which we just don't think is right. So the company you would probably look to, IBM, and say, 105 years, you guys are pretty old, stodgy, and closed, right? We're actually the more open server company in the industry right now. created incredible innovations to solve many of your needs around big data and many of your peers. And then, of course, there's thousands of ISVs and tens of thousands of open source packages. So yeah, we're all in on open and all in on open source. So that's kind of the ecosystem point. Now, clients, maybe examples. I don't know if you know the clearinghouse. They're one of those little sort of U.S. Entities behind the scenes that transfers half of the funds every day. Every day. $2 trillion a day, 2,500 transactions a second. The problem they're wrestling with is if you transfer money from one of your banks to another, hopefully legally, back to how Emil described, an illegal transfer of funds or financial institutions, that typically takes, 24 to 48 hours to clear? I think that's sort of the norm today. There's that checking that goes on to make sure it's going from the right place to the right place and so forth. It's frustrating if you're trying to make a rapid purchase or investment or something. You've got to wait 24 to 48 hours. A whole lot of stuff can change. You can miss a moment. So what they're working on is real-time banking. When you hit transfer, those funds are automatically cleared the moment you hit the trade. So that's what they're working on. They're a new Power client. They're running the database on Power. They're running the applications around real-time bank transfer now on Linux on Power. So this is a client. They're not yet running acceleration, but I think as you can imagine, given their scale, how important that could be in the future. So an example of a client doing this. So let me start to wrap up here. My points of going through this is one, to go to the sort of lowest level of the stack, the hardware space, where me and my team live every day. There is incredible technology innovation happening, technology disruption, and I want you to know as you think about the platforms to deploy Neo or your other data needs on, there is a choice versus Intel in the marketplace for you to consider today that you might not have considered before, for whatever reasons. That choice is Power and the IBM servers. Secondly, from a collaboration, if you're an ISV, a business partner, a technology innovator, a startup, and are looking to take advantage of some of this innovation I've talked about to join Open Power, come join us in this movement. Come join us and be part of this community we're creating here, leveraging, again, as I said, the principles of open source software, the ideas that the ARM processor is a licensed processor for all your mobile needs. Those same principles apply here now in the enterprise server space. So we're creating that ecosystem, and it's growing every day. And finally, if you want to talk more, we're happy to talk later in terms of business model innovation and how you got to be prepared to disrupt yourself. After 105 years, that's what we've learned. You can't sit steady. You can't hold the wheel tight. You've got to be ready to let go and sometimes let the car drive itself. You got to be ready to be disrupted, or somebody else will disrupt you. So I wanted to thank the team from Neo4j for the opportunity to come and speak with you this morning. Hardware is an exciting place to be, and we're excited to be part of the partnership with Neo4j. So Emil, back to you.
Thank you, Doug.
While much of the stuff that I talked about today with Neo4j 3.1 was really about horizontal scale out, right, with the new clustering architecture, like, do not rule out scale up. There's this huge trend actually going on right now where some people call it like big memories eating big data, actually. And scale up systems are absolutely amazing sometimes for in the right situation. And no one builds better scale up systems than IBM. So I urge you to check it out. We're going to wrap up here. Just a couple of super quick closing thoughts, right? So it's very clear from our vantage point that we're entering the connected age, right? Everything is becoming more connected, right? People are becoming more connected. Processes are becoming more connected. Places, products, devices, everything is becoming connected. And how I see our role is give you the technology so that you can respond to that increasingly connected world. Now, at every single Graph Connect, my last slide is always this slide. That's not showing up yet. It would be amazing if we had AV problems, but it worked flawlessly once we got started, right? All the way up until the last slide. I can show the last slide. So So the last slide is a picture of the most powerful database on the planet, right? And what is that? It's the human brain, right? And how's the human brain structured? It's a graph, right? It's neurons connected to other neurons through synapses, right? And what's amazing about yeah, there it is. And what's amazing, I think, about the human brain is not just that it's a graph, although I get very excited about that, but it's that it helps to make sense of data. It doesn't just store data, it makes sense of it, right? And there's so many databases out there these days. There's whatever, it used to be 4 databases only, right, back in the 90s. Now there's hundreds of databases. And many of them are amazing. Most of them are amazing. They're scaling up and down and left and right, and they're cloud-friendly, and like all kinds of things. But fundamentally, what they all do is that they store and then they retrieve. They store the data and then you retrieve exactly that data. And we at Neo4j have much higher aspirations than that. We want to, like the human brain, we want to make sense of that data, help you make sense of that data. Whether it is in your hobby project, right, or in the startup that you're doing, because this is Silicon Valley, hopefully enrolled in the Graph Incubator, or in that increasingly connected enterprise. So I started out with one ground rule. You know, I don't want your undivided attention. I don't want your undivided attention. Please tweet, right? So my second ground rule that I always end with at Graph Connect, many of you will recognize it. So my goal with Graph Connect is for this to be an amazing day for all of us, like exciting, new technology, new ways of doing things, solving problems. You should all be challenged. You should all be inspired, right? But I also want Graph Connect to be the friendliest conference, right? And that's on you, right? That's on all of you in this room, right? We're graph people here. We're relationship people. Don't be tragically isolated documents, okay? The homework to all of you is to strike up conversations with your fellow attendees. Ask them about, you know, how did you like the keynote? How do you like Neo4j? How did you get started with this? What do you think they should improve? Talk. And in one word, of course, connect. Thank you, everyone, so much for listening, and have a fantastic day.